Okay, so here we are, crystal violet. So after you get your data, you're going to then make some plots in Excel. So you're going to do just set up in a column and have time versus absorbance, and then make another column where you calculate the ln absorbance and inverse absorbance, and you'll make some graphs then for these. And we're going to try and fit these trends to figure out which one's the most linear, but you don't want to include that initial data before you inserted the QVAT. So what you want to do is you want to change the cutoff to account for when you put the QVAT in. All right, you don't want to have that rise; it'll shift it. Okay, and then once you find the one that's most linear, then it'll tell you is it zero, first, or second order, and the slope will tell you K prime. And remember, this is the rate law we're trying to solve. And in the first run, we have such a high base concentration that this remains constant. So the rate law looks like this. All right. So from trial 1, we'll get the order and then the rate constant. In trial 2 and trial 3 will give us then y. Most of you, this is going to work. Some of you, you're going to find this absorbance, because the colorimeters aren't that good, is going to go negative at the end. So what you have to do is you have to shift it up to have it go to 0. And so you're going to take that the absorbance, the last absorbance, and simply add it to all the points, and then you'll do the exact same thing. All right, so you'll shift it up, and now you'll have the same kind of trend line, except for now it won't mess up these by passing through 0 and becoming negative. Okay, so then, like I said, you're going to choose which one's the most linear using the r-squared value, and that'll give you the order. Then trial 2 and trial 3, you'll do the same thing. So you're going to get the relationship for trial 2, trial 3. And what you need to do then is you need to calculate the concentrations of the base. And we want the base in the actual run for it. And so once you get that, now you can plug in those values. You'll have this number from the slopes. You'll have these values from your concentration in the reaction mixture, and then you can determine what's the order of y. After you do that, now you can plug into the experiment 2 or experiment 3, but not the first one, because remember, it was pseudo, and we're able to solve for then the rate constant for it. All right, so that's the process. You make the plot, determine which one's the most linear, use the trend line to get the K, do the same thing for trial 2, and then uh, determine those diluted concentrations, and then do the concentrations. It's again a 1-to-1 dilution whenever you mix it. And now you can plug in those values and solve for the order y, and or for the rate. Actually, this is what you do. We know this now, and we know the concentration from either trial 2 or trial 3, so we're able to solve for K. All right, and now you just substitute in the values into here, and that gives you your overall rate law. Then you have some post-lab questions that should be straight.